Welcome to the Osmosis and Diffusion Laboratory Experiment. We have two experiments that we're going to run today. We have the egg and osmosis experiment, and we have osmosis and diffusion across a semi-permeable dialysis membrane. Okay, let's start with the osmosis and diffusion across a semi-permeable membrane. You remember from the lecture that a semi-permeable membrane means it only lets some things cross the membrane, and usually it's based on size. So the dialysis membrane that we have right here is basically a piece of tubing that has small fixed pores in it that would allow small things to move across the membrane, but not large things. Okay, so here's what we're going to do. We're going to tie a knot in one end of this dialysis membrane because we are going to add solutions to it. Okay, we're going to open it up here. That's the tricky part, so that we can add our reagents. Okay, here's what we're going to add. We're going to add 2 pipettes full of 15% glucose. Okay, here's 1, and there is 2. All right, good job. Now we're going to add 2 ml, 2 pipettes full of 1% starch. Okay, had to mix it up. It was getting a little settled on the bottom there. There, plugged up. Okay, got starch added to it. Okay, excellent work. All right, now what we're going to do is we're going to put that tube, that dialysis membrane, see how it's murky, cloudy white. We're going to put it in a beaker. We're going to use a rubber band to hold the open end in place so it doesn't slip into the beaker. We're going to add enough water to the cup to cover that tube, and then we're going to add iodine to the water, enough to turn the water visibly yellow. Then you're going to set your timer for 30 minutes, and we're going to see what changes occur to the contents of the bag, what it looks like, and we want to know, does anything inside that hypertonic bag containing a high concentration of glucose and starch, can the glucose cross that membrane? Can the starch cross that membrane and get into the beaker water? So here's the principles. Glucose, right here, is a simple carbohydrate. It's a monosaccharide, mono meaning there's one sugar molecule in it. Starch, on the other hand, is a complex carbohydrate. It is made up of many repeating sugar units. A starch is a complex, large polysaccharide. Okay, so remember what I said about the dialysis membrane or a semi-permeable membrane. It has fixed pores that only allow small things through, and big things are going to have a hard time coming through. Okay, another principle. Iodine will react in the presence of starch and turn it bluish or blackish. So, that is how we're going to determine, does starch cross the membrane? Because if we put iodine in the beaker water, then that water would turn bluish or blackish. Okay, now how are we going to know if glucose leaves the bag? Well, we have glucose test strips, and then we're going to swish that test strip in the water and see if glucose left the membrane. All right, but set your timers for 30 minutes and then we'll wait. Nope, fooled you. Time warp. This is already sat for 30 minutes, okay? Notice the beaker water is still reddish orange from the iodine. That water in the beaker is not bluish or black. That means starch did not leave the membrane. I wonder why that was. Okay, here is our bag, and please notice all the bluish blackish that's in that bag. I think that iodine and water might have entered that bag. Remember, the bag is hypertonic, and the beaker water was less concentrated. There was a lot of glucose and starch in this bag. Think about how water carrying iodine would move across a membrane to dilute a hypertonic solution. There's a term for that movement of water. Okay, that's going to be in your questionnaire. Okay, now we want to know, did glucose leave the bag? We know starch didn't. So we're going to use a test strip here. There we go. I'm going to swish it around in that water really good and give it a minute to react and see. Originally, that test strip was almost turquoise. Okay, we're going to give it a minute because these are some old strips. So if that turns a level of green or brown, we're going to give it a second here. I already know it's measuring glucose. Okay, starting to turn a little different. Fits right here now. And if I left it sitting for maybe 2 or 3 more minutes, it would get darker and darker and darker. So it's definitely not negative. Okay, so that means that glucose left the dialysis membrane, crossed that membrane, and got into the beaker water. What is the name of passive transport by which a small molecule like glucose could move across a membrane across to the side where it was in lower concentration, is going from where it's high concentration inside the bag to low concentration in the water? What was that term? All right, we'll stop, we'll pick up and check up what's going on in our other experiment.